So next class we're going to be working with 8.5, the section on power series. Power series is like an infinite polynomial. It's anything of the form c sub n x to the n from n equals 0 to infinity. So c0 plus c1x plus c2x squared and so on. Sometimes we let the x have a different center, by which I mean if I plug in 0 to all of my x's, then all of the other terms go to 0 and all I'm left with is c naught. So that's the center because it killed off all but one of the numbers. So if I want a different center, I might write c sub n x minus a to the n, which would be c0 c1 plus c1 x minus a plus c2 x minus a squared and so on. Then the number that makes this 0 is an a. So a is our center. So if we look at the problem we're given here, we know that our center is 5. Center equals 5 because it's the number that's being subtracted from x in every term. And then we've got some coefficients, the 2 to the n and the n plus 1. When you're looking for where a power series converges, we always use the ratio test. It does a lot of good stuff for us, but it has one weird thing now, and that fact is that we have x's, so it's going to change how we treat a lot of this stuff. So we're going to let L be the limit as n goes to infinity of the absolute value. Right terms with a plus 1, x minus 5 to the n plus 1 over 2 to the n plus 1, n plus 1 plus 1, which is n plus 2. Now you flip and multiply, so you're going to get an n plus 1, a 2 to the n, and an x minus 5 to the n. So that's what we're going to take the limit of. In the ratio test at the end, we're going to set it less than 1, but that's not natural. We want to solve when it's less than 1. So we do any simplifying. This is the limit as n goes to infinity of the absolute value. The 2 to the n's line up. The n plus 1 and n plus 2 line up because they're both polynomial. And the x terms line up pretty nicely. Now you can do this in one step, you can do it in two, however you want. We see what cancels. I've got a lot of I've got n many 2's in top, and n many of them will cancel, so I'll be left with one of them in the bottom. So this is now L equals the limit as n goes to infinity of, also notice what happens with our absolute value. The x term could be negative, plus or minus. The n plus 1 and n plus 2 can only be plus, and the 2 to the n can only be plus. So the only term that still needs the absolute value is the x term. So when we cancel, we're going to have a 1/2, the 2 that's left over. We're going to have an n plus 1 over an n plus 2. Those don't cancel because of the pluses. And then we're going to have an absolute value of x minus 5 because there's one left on top. I pull it over to the right because it's so different, we're usually going to treat it that way. Now, the ratio test says that we converge if L, which we have here, is less than 1. So that's what we want to solve. We need to take this limit to see when it is less than 1. When we take the limit, notice that the n is what's changing. N is changing, not the x. So we're going to take the limit and notice that as n approaches infinity, the leading term is going to approach 1/2. So this is L equals 1/2 x minus 5. And we want to set that by the ratio test to be less than 1. So when we're solving this in an algebra class, or we're solving it in a geometry class, there are two slightly different ways to look at it. So there's the algebra method and the geometry. They both start with the same step, and that's isolate this x minus 5. So I'm going to take this line and rewrite as x minus 5 is less than 2. Multiply both sides of our inequality by 2. In an algebra class, you turn your inequality into a pair of inequalities, negative 2 less than x minus 5, no absolute values, less than 2. And in a geometry class, we would say that the center is 5, and the radius is 2. So we're looking at the number line. We go to the 5, because the absolute value, x minus 5, means the distance between x and 5. So this is saying, when is the distance between x and 5 less than 2? Well, that's any time you're within 2 of the 5. So I'm going to go for my 5, I'm going to go left 2 to the 3, and right 2 to the 7. So anytime that I am inside this bubble, on this part of the interval, I'm going to have convergence because my ratio, my L, will be less than 1. And anytime I'm outside, my L will be bigger than 1, so it'll diverge. What we don't know is what happens at the endpoints. If we're doing it algebraically, you see that you've got negative 2 less than x minus 5 less than 2, so we're going to add 5 to all three terms. Negative 2 plus 5 is 3, less than x, the 5's cancel, less than 2 plus 5 is 7. And notice we get the same description. Anything between 3 and 7 here matches anything between 3 and 7 over there. So two different ways to see the same fact. In both cases, our center is 5, but this one, you don't see the center written center. You have to think of a little bit. Here the center is clear because it's written in the absolute value, x minus 5. So, we know most of our answer. We know the interval on which it's true inside endpoints, and it's false outside, but we still have to check endpoints. We always have to check them if we have a finite radius. Oh, and in our picture over here, we should say that our radius is 2. So we're going to check our endpoints. We have to plug in both endpoints. The first one we plug in is the 3. I'm going to take my original series from the top, and I'm going to plug in a 3. From n equals 0 to infinity, 3 minus 5 to the n over 2 to the n times n plus 1. And you simplify. 3 minus 5 is just negative 2 to the n. We still have our sigma. From n equals 0 to infinity, negative 2 to the n over 2 to the n times n plus 1. Negative 2 to the n over 2 to the n will cancel to be a negative 1 to the n. For a lot of people, you should write this as negative 1 to the n times 2 to the n so you don't get confused. So the 2's cancel and the negative 1 is left. So we've got the series from n equals 0 to infinity, alternating negative 1 to the n over n plus 1, which we can show work. For space, I'm going to stop, and get that it will converge by the alternating series test. So we converge at 3, so that's a good number. So we now know that on our picture, when we've got our 5 and we've got our 3, we're going to include the 3 as part of our interval. We still don't know about the 7. So we're going to check that. When x is 7, you're going to plug in the series from n equals 0 to infinity of 7 minus 5 to the n over 2 to the n times n plus 1. That simplifies to be the series 2 to the n over 2 to the n times n plus 1, and we're still put our n equals 0 and infinity. The 2 to the n's cancel, so that's the series from n equals 0 to infinity of 1 over n plus 1, which is similar to the p-test, so with comparison or limit comparison, we can show work to see that it will diverge. So our final answer is that our center is 5, our radius is 2, and our interval of convergence is including the 3 and not including the 7. And that's our final answer. Okay? Meaning any number in this interval we can plug into the function, into the series, and get a constant number, or get a finite number. And if you plug in any other number, the series will diverge.